Hi, I've been introduced to you already by Ian. I'm Ludovic, and tonight I'm going to give this webinar to you. As you understand from the way I'm standing now in front of you, this is not completely live, it's semi-live. I have been taping this webinar on beforehand, because I think that's easier. And then during the webinar, I'm present on the chat. If you have a question, just type it immediately and I try to answer you. At the end of this webinar, then I will stop the video and I'll come back to you live, and I might answer your questions live. So yes, I'm there. Please ask any questions. Don't wait with it till the end. I'm just my own assistant right now, but I won't stop this video. So I'll start right now, and I'm starting with there's music in STEM. Hi. This is a webinar about music in STEM. Science, technology, engineering, and music. Math. Okay. I'll first introduce myself. I'm Ludovic Wallard. I'll tell a bit about myself. Then I tell you what this workshop is actually about. And then we go through the workshop. And I'll give you, the outlines just a bit later on as well. I'm Ludovic Wallard. I'm a teacher in the Netherlands, and I teach in grade 7 to 12. Basically, I'm a math teacher, but before that, actually, I'm a philosopher. I've been able to teach Greek, Latin, woodworking as well. So whatever you give to me, I'll do it. And in the past 3 years, I've been teaching STEM, so I'm very happy about that. STEM is still a minor part of my job. Basically, it's math. I'm a member of TQ Benelux. Some of you might have seen some Dutch tutorials about the TI-Nspire or the TI-N4. Well, together with a colleague of mine, together with Frank, we make these videos, and you can find them under Wilde Wiskunde. And actually, we're quite successful because we have far over 300,000 views right now. So our students, they really do like it. What I'm going to show you is, in this webinar, is how you can program music in the calculator, in the handheld. And why do I do this? Well, this is actually something which I've been doing in my classes. I've been doing it with students in grade, what was the youngest, in grade 6 up to grade 9. But I've also been doing it with grown-ups, with math teachers, with colleagues of us. And in this webinar, I'll show you what I do. And since we're not live and we can't, work on the Nspire and the hub at the same time right now, I'm just going to explain you what I do. And you can't experience it right now during this webinar. Just please try afterwards. I wanted to program music on the handhelds. If I want to put some stress in programming, I want to learn structures, then, programming is important. Then I send them first to TI codes. And I use a few lessons to have them introduced to TI Basic, or in the near future to Python. This webinar, alas, is only with TI Basic. I'm sorry. But it's both about the Nspire and the 84. If I want to do more thinking, then I have them thinking, how should we put the music into the machine? We do that actually by putting the notes, the frequencies, in a spreadsheet, in a list. And then the length of the notes we put also in the spreadsheet. If I want to stress the mathematical part, then I can start with a formula, because you can describe musical notes with an exponential function. I'll come to that a bit later. Usually for me, when I don't have too much time for this, and then I think about maybe 1 or 2 lessons of each 50 minutes, then I just focus on solving the challenges. First about the exponential function. I don't know too much about music. I have 2 daughters, they play the guitar and the flute, so they have introduced me to the music. But, well, I'm sorry if I make some mistakes. Actually, right now what you can see is the piano, with the black and the white keys. Usually, musicians, they start not with the A. I start with the A, because that's a nice figure for the frequency, that's 440 Hertz. Usually musicians start with, for example, the C. And I've also learned, and I don't know exactly about it, that maybe the letters will not be actually the same in each and every country. So it's not completely universal. The frequencies and their the formula behind it, that's universal, so don't worry, you can always switch it to your own system. I start with the A, I call it 0. Then I go to the first black key, that's the A sharp. You can also say it's the B flat. Sharp means we go to the next one, flat we go to the previous one. The black key is in between the A and the B. That's number 1. Then we go to the B, C, and then we have the C sharp, or maybe the D flat, D, E, and you go along. Then the G is the last one. No. Then the G sharp is the last one, that's the black key. Then we get the A, which is again in the next octave. That's number 12. Actually, 1 octave goes from number 0 to number 11. And then number 12 is the next octave. The next A, the frequency, is double the frequency of the previous A. So we go from 440 to 880. And all these 12 steps in between, they are 1/12 of this times 2. And I don't mean it's linear, but it's exponential. So it's actually 2 to the power of 1/12. Each and every step from the A to the A sharp, the black key, that's 2 to the power, frequency 2 to the power of 1/12. Then again 2 to the power of 1/12. 1/12 of these 2. So we get to the formula. The frequency is 440 times 2 to the power of n, the number of steps you take, divided by 12. If you look at the table, actually I've only the white keys in the table. I go from A, B, C, D, E, F, G, and not the black keys in between. That's because on musical stuff, the many lines with the notes on top of it, there we don't have a separate symbol or a separate line for if you have the A sharp, for example, or that's the same as the B flat. Then you have the symbol of the A with another symbol next to it, which means you have to take the A and you go 1 higher. Or maybe then you write down the B and you do 1 lower. So that's why I don't have them in the table. Because then my table will be most congruent, synchronous with the stuff. These are of course just a few lines of the table. The other lines you can imagine how they go. What are now the challenges? Well, basically, if the challenges are, how then should I program these black keys on the piano? How should I write them down in my program. Well, you don't have a clue about the program yet, probably that will come in a minute. What do we do with notes in another octave? Should I put all the, what is it, I think over 50 keys on the piano, should I all put them in my program? Because I want to be able to, play each and every song? Well, we can do it, but let's make it a bit more efficient. Let's not do that. What to do with the rest? Sometimes there's no music. But in this formula, an exponential formula will never be 0. But, of course, it will come close to 0 if the exponent is, well, the right one. So, now I give you already a clue about the solution, but my students have to think about it. How should they program it? We want a simple notation. We want a program which is short, which is easy to understand, but which also has the possibility to put in one song or another song, and it doesn't matter. So you have one program and the song is separate. You don't want that as soon as students start programming, they will be able to produce a sound through the Innovator Hub, and then the problem is that the first sound has started and immediately the program plays the second on top of it. And then they have to think, okay, what's going wrong? Why is this happening? How should I solve this? That's what we're going to do in the program. They have to think about it. And that also has to do with the pace, with the speed. How fast do we play a song? Not every song is played in the same speed. And then also students will find out that if they put in the notes, then it will sound a bit staccato. The first note will be finished, and then the second note will start. And it's not fluent anymore. So how should they solve these problems, these challenges? And then I have my students thinking, especially if they can take a song of their own. Then you make it a bit more personal. Usually I take my songs because then I prepare the music, and I take songs that everybody knows. Here you see a table with actually small parts of 2 songs. The first 2 columns, they are notes from Happy Birthday. And what you can see, in the first column, I have put the notes. I've put a G, F plus 1, that's actually F sharp, that's the black key next to the F. Then D, D, E. In the second column, still for Happy Birthday, I have put the length of the notes. So that's 1/4 note, half note, 1/8, 1/8, and again a quarter note. In the third and the fourth column, there's a Dutch song, Land van Maas en Waal. You won't know it, and I won't be playing it. But there you see in the last 2 lines, line number 8 and line number 9, A plus 12. That's actually an A in 1 octave higher. I told you I don't want to program all the notes, all the keys of the piano. So I just program 1 octave. And if it's an octave higher, I just say plus 12. And if it's still an octave higher, then it's plus 24, of course. Okay, now comes the program. And I'll just explain you about the program. Because I think as a teacher, we should understand the program. And I think it's a nice program because it's very short. It's quite very easy to understand. Very often, this is not the part that I'm doing with my students. Very often I just have them thinking about how to put the music inside. But on each and every level you can play with it. there's many possibilities. This is not, you shouldn't take this webinar to take to the classroom tomorrow, because I'm just explaining you what kind of information you can use. First, I define my first octave. And as you see, the A is 0, the B is 2. Yes, the black key was number 1. That's not there. The C is 3. Then there's another black key, so there's no 4. And then I go on. And the last line, the blue one, that's the rest. I wanted my frequency to be almost 0. Actually, I want it to be 0, but I can come close to 0. So that's why I say my rest is minus 200. Then my exponential function, it's close to 0. The innovator hub won't produce any sound anymore. So minus 200 is okay. I've not tried it yet, but probably minus 50 will be also fine. Minus 2000, of course, it will be fine. Just it should be so low that the innovator hub won't produce any sound anymore. Then I'm not going to put my song in my program, because that makes my program not fit for other songs anymore. So I put my song outside the program and I put it on a spreadsheet. This I told you already. I have to get my information from the spreadsheet. I showed you the spreadsheet. So with note, I go to the first column where you saw the G and the F plus 1. That's my note. Then the second variable that I'm using is the length. That's the second column actually. Then I have to go through the song. Some songs are long, some songs are short. So my program should know how long it should go on. Because maybe if I produce a shorter list than what's programmed, then you get an error. So therefore, I have my program looking into the column. What's the dimension, what's the length of my spreadsheet? For the index I is 1 to the dimension of note. Note is my first column. The dimension is the length of how many notes are there. So I have a for loop. And then I'm going to set the sound. And there you see the formula. 440, that's the basic A, times 2 to the power of, and then I have the note. If there's an A in my spreadsheet, and you see on the other side the A is 0, that I have defined before, and then you get 440 times 2 to the power of 0/12. Or maybe if it's a D, then it will be 5. Then you have 440 times 2 to the power of 5/12. Okay, that's the frequency, that's the right sound. Then in sense sound, you also have to tell the time. And the time will be, coming from the second column, and we refer to that with length. Now I have sent the sound to the Innovator Hub. And the sound will be played for the length that we've put in the second column. But then, if you just finish your program here, if you finish your loop here, and it will go back, then immediately on top of it, the new note will be displayed, will be heard. So that means that the Innovator Hub actually doesn't have any time to finish what was sent to it before. It won't be able to finish maybe this half a note, because the next one is already on top of it. So we have the innovator to wait till the first note is finished and then go on to the next one. That's a very special thing that you have to understand when you program. You might send the information and you say in the information, have this sound for so long, but then if there's another commands on top of it, well, the first command just disappears. That's why we have to command wait. If you just wait the time that's written in the table, then you will hear that the music is a bit staccato. Then the first note will be finished, so you get the music and then it's finished, and then the second note starts. Every time there is some kind of click in between. That's of course not nice, you want to have it fluent. So now what we do is that we take a little bit less time before we send the next note. We take 90% of the time. So after 90% of the time, that's why I say multiply by 0.9. After 9% of the time, we send a new note. And then you'll hear it. Of course, if now the speed, the pace of the music is too quick, you can change this. If it's too slow, you can change it. And also, if it has to go much slower, then even in the previous and also this line, you can multiply length, for example, by, if you want it 50% slower, then you say multiply by 1.5. Now the for loop has ended and we have our program. We have the table, I showed you before. We have the program and this is everything. Then, well, everything, this is our hardware, the hardware for playing music. Then we have to put the music into the calculator, into the table. So how should we do that? That's the next thing. Actually, before I go to that, I'll show you how to do it in the 84 as well. And I'll go through this quickly because it's basically the same, but not completely. In the 84, of course, we can't calculate with letters. So I can't put in an A or B, a C, a D, or whatever. So in the 84 I'm still using the numbers. That's more difficult because then if I see the musical script, if I see the stuff, the musical notes, then I can't think in ABC, but I have to think in the A is 0, the B is 2, the C is 3, the D is 5. I have to think in these numbers. And these numbers I put in the list and I put them under L1. In L2 I put the frequencies, not the frequencies, I'm sorry. I put the length, and then actually I have the same system. You see the program. First everything should be cleared, that's easy. Then I look for the dimension for the length of my table, dimension of L1. Here you see the formula, and though I should be able to put it in the send set sound command, I have over here the formula first put it into F for frequency, and then later on I put it in the send set sound command. That's what I'm doing here. Send set sound evaluate F. Then actually this line is a bit more, well, more beautiful, less less busy with all these formulas inside. And the time part of it will be the same. Evaluate the second column, the second list. Again, wait for 90% of the time and then go to the next one, and then we're finished. This is actually everything you need. How to get this table? Well, usually I hand out some music, of course, and I have to give some instructions. Here you see the chart with instructions I give. You see the musical stuff with all the notes. I've given the names. I've given some numbers, and also that, like for the first D, which is a bit on the left side, that's one octave lower, so that's the D minus 12. The symbols for the sharp and the flat I've shown. Actually, I don't know them in English, I'm sorry, but the flat, then you take the note minus 1, and if it's the sharp, you take the note plus 1. Of course, I have to tell about the length of the notes. What do they mean? Half a note, a quarter of a note, an eighth of a note, whatever, it's there, and the rest as well. And there are, in many musical parts, also some extra details that you have to know if there's a note with a dot behind it, it means you have to expand the note in time by 50%. With this information, I give the music, I give this chart, I give the music, and together I have my students and I let them produce a song. Okay, thanks for watching. What I've been doing is giving you a webinar as if you were sitting in front of me. Unless it was less interactive, it was not interactive at all. That's what I usually do when people are in front of me. And this is the webinar that that I've been giving a few times to teachers. I'm explaining what I'm doing. This is not the same class that I'm doing with my students. With my students, of course, I just give them the music, put in the music in the spreadsheet, or I just give them the assignment, program music in the Nspire, or in the 84, whatever. And then, well, of course we've gone through TI codes, they know how to get some sound from the machine, and we'll have to ask the right questions. But, well, I can do many things. If I just want to talk about frequencies, if I just want to do a math class about exponential functions, then well, I can go on with frequencies and whatever. I have to calculate their things. So, thanks for your attention. This part will be finished. I'm finishing now the video, the tutorial, well, it's not a tutorial, the webinar, and then I'm coming live to answer some questions in this way. So, thank you very much, and if you're leaving, have a nice evening.